Hello everyone! In this video, we're going to discuss and solve problems regarding the derivatives of trigonometric functions. But before we can do that, let us first familiarize ourselves with the different formulas involving derivatives of trigonometric function. So let's start with sine of u. So if we are given a trigonometric function sine of u, where u is a function of x, and if we're going to solve for the derivative of sine of u with respect to x, then this would now be equal to cosine of u multiplied by the derivative of u with respect to x. Right? So this would be our first formula. Next, for the derivative of cosine of u with respect to x, again, where u as a function of is a function of x, then this would now be equal to negative sine of u multiplied by du over dx. For the derivative with respect to x of tangent of u, where u is also a function of x, then this would now be equal to secant squared of u multiplied by the derivative of u with respect to x. For the derivative of cosecant of u, right, so with respect to x, this would now be equal to negative cosecant of u cotangent of u du over dx. For the derivative of secant of u with respect to x, this would now be equal to secant u tangent u du over dx. And finally, for the derivative with respect to x of cotangent of u, where u is a function of x, this is now equal to negative cosecant squared of u du over dx. Right? So these are now the formulas that we are going to use in determining the derivatives of trigonometric functions. Now, it is important to note that since we are dealing with trigonometric functions, we might have different approach in solving problems like this. So it is essential that we are familiar with the different trigonometric identities. So to illustrate, let's have this first example. We are given y equals sine of 3x and solve for y prime. Now, if you're going to inspect the given is a trigonometric identity, and this given is in the form of sine of u, where u in here is 3 multiplied by x. So if we're going to solve for the derivative with respect to x of sine of u, then this is now equal to cosine of u multiplied by the derivative of u with respect to x. So solving for y prime, this is now equal to cosine of 3x, right? Because u is 3x and cosine, so we're just going to put it here, cosine of 3x multiplied by the derivative with respect to x of u, which is now equal to 3x. So solving for the derivative of 3x with respect to x, then this is now equal to cosine of 3x multiplied by 3. And simplifying this one, y prime is now equal to 3 cosine of 3x. Another example that we have in here, we are given y equals 2 cosecant of 1 minus 3x and solve for y prime. So in solving for y prime, the given function is in the form of cosecant of u. And solving for the derivative with respect to x of cosecant of u, then this is now equal to negative cosecant u multiplied by cotangent u multiplied by du over dx. U in this given would be 1 minus 3x. And this 2 here is a constant. So solving for y prime, this is now equal to 2 multiplied by the derivative of cosecant of 1 minus 3x, that would now be negative cosecant of 1 minus 3x multiplied by cotangent of 1 minus 3x multiplied by the derivative with respect to x of 1 minus 3x. Right? So in here, we applied the formula. And simplifying this is now equal to 2 multiplied by negative cosecant 1 minus 3x cotangent 1 minus 3x multiplied by the derivative with respect to x of 1 minus 3x, that is equal to negative 3. Right? So this is now equal to negative 3 multiplied by negative multiplied by 2, so that will give us positive 6 multiplied by cosecant of 1 minus 3x cotangent of 1 minus 3x. This is now y prime. Another example we have in here, we have y equals tangent of x sine of x, then solve for y prime. Now, this one, or this given function, it is in the form of tangent of u, where u is equal to x sine of x. Now, this u, which is equal to x sine of x, this is in the form of u multiplied by v, wherein your u here is x and your v here would be sine of x. Now, it is also important that you are familiar with the derivative of a product, and the derivative of a product would be u dv over dx plus v derivative of u with respect to x. Now, if we're going to apply these formulas in this given function, solving for y prime is now equal to the derivative of tangent with respect to x is equal to secant squared u du over dx. Right? So, using this formula first, we now have secant squared of x sine of x. Right? So, this is secant squared u, and since u is x sine of x, then this would now be secant squared x sine of x multiplied by the derivative with respect to x of x sine of x. Now, this x sine of x is in the form of u multiplied by b, so solving for the derivative of x sine of x, then this is now equal to secant squared of x sine of x multiplied by the derivative with respect to x of sine of x plus sine of x multiplied by the derivative with respect to x of x. So this is now equal to secant squared of x sine of x multiplied by x. The derivative of sine of x is cosine of x plus sine of x multiplied by the derivative of x with respect to x, so that's equal to 1. Alright, so if we're going to simplify this one, this is now equal to secant squared of x sine of x multiplied by x cosine of x plus sine of x. And since the resulting expression cannot be simplified any further, then this is now our y prime. So another example we have in here, we have y equals tangent of x sine of x, and we are going to solve for y prime. Now, if you're going to inspect the given function here, we have tangent of x multiplied by sine of x. So basically, we have a function which is in the form of u multiplied by v. And the derivative of u times v is equal to, right? So if we're going to get the derivative of u times v, so that would now be u multiplied with the derivative of v with respect to x plus v multiplied with the derivative of u with respect to x. Now, since u in here, right? So since u in here would be tangent of x and sine of x would be our v in here, the derivative of tangent of x or tangent of u generally, then that is now equal to secant squared of u du over dx. And the derivative with respect to x of sine of u is equal to cosine of u du over dx. Now that we know all the formulas that we are going to use, then we can now solve for the derivative of tangent of x multiplied by sine of x. So solving for y prime in here, then this is now equal to u is tangent of x, right? So that would now be tangent of x multiplied with the derivative with respect to x of sine of x plus sine of x multiplied with the derivative with respect to x of tangent of x. So u dv over dx plus v du over dx. Alright? So solving for the derivative of sine of x, which is equal to cosine of x multiplied with the derivative of x with respect to x, so that is basically equal to 1. So this is now tangent of x multiplied by cosine of x plus sine of x. The derivative of tangent of x is secant squared of u du over dx, and since u is x, the derivative of x with respect to x is equal to 1, so this is basically equal to secant squared of x. Right? Now, tangent of x multiplied by cosine of x can still be simplified because tangent of x is equal to sine of x over cosine of x. So if we're going to multiply this with cosine of x, then cosine will cancel out with cosine. Plus sine of x multiplied by secant squared of x, alright? So let's just leave it as is because we cannot cancel out anything with that anyhow. So this is now equal to sine of x multiplied plus sine of x multiplied by secant squared of x. Now, if we're going to bring out sine of x, or if we're going to factor out sine of x in here, so this is now equal to sine of x multiplied by 1 plus secant squared of x. Alright? So this is now y prime. Let's have the next example. We are given y equals cosine of t raised to the 4th power minus sine of t raised to the 4th power. Solve for y prime. Right? So before we proceed with the solution here, let us first identify the different forms involved in this problem. Now, this cosine of t raised to the 4th power can be written as y equals cosine of t quantity raised to the 4th power minus sine of t quantity raised to the 4th power. So since we are given a power here, then one form involved is u raised to n. And the derivative with respect to x of u raised to n is equal to n u raised to n minus 1 du over dx. Also, we have in here cosine of u and sine of u. So the derivative with respect to x of sine of u is equal to cosine of u du over dx, and the derivative with respect to x of cosine of u, that is equal to negative sine of u du over dx. Right. Now that we already know the formulas that we need to use, then we can now proceed with the solution here. So y prime, that is now equal to, right, so since this is u raised to n, derivative with respect to x of u raised to n is n u raised to n minus 1 du over dx, so that would now be 4 multiplied by cosine of t raised to 4 minus 1, alright, so that's 4 minus 1, so that is equal to 3. Multiplied by the derivative with respect to t, right, since our our independent variable here would be t, so that would now be the derivative with respect to t of cosine of t. Minus, right, so the derivative of sine of t with respect to t raised to the 4th power, so that would now be 4 multiplied by sine of t raised to 3 multiplied with the derivative with respect to t of sine of t. Alright, so this is now equal to 4 cosine cube of t multiplied by the derivative of cosine of t, so that's equal to negative sine of t minus 4 multiplied by sine cube of t multiplied with the derivative of sine of t, so we have cosine of t. Now, if we're going to inspect the resulting expression here, we can actually factor out negative 4 sine of t in here, and then we can also factor out negative 4 cosine of t in here. So our common factor here would be negative 4 sine of t cosine of t. So if we are going to bring out 4 sine of t cosine of t here, the remainder would be positive cosine squared of t. Right? So again, if we're going to bring out sine of t, and then 4, and then 1 cosine t here, the remainder would be cosine squared of t. Similarly, if we're going to factor out negative 4 sine t cosine t in this term, then the resulting answer would be positive sine squared t. Right? So we brought out 4. We brought out 1 sine t in here, and then we brought out cosine of t. So the remainder is sine squared of t. Now, cosine squared of t plus sine squared of t has an identity, and this is equal to 1. Right? So you have to know that sine squared of x plus cosine squared of x, that's equal to 1. And since this one is cosine squared of t plus sine squared of t, then that's also equal to 1. Also, another identity that can be found in this problem would be sine of 2x. Now, sine of 2x is equal to 2 sine of x cosine of x. So if I'm going to write this term or this expression as negative 2 multiplied by 2 sine of t cosine of t, then this is now equal to negative 2 multiplied by sine of 2t. So this would now be our final answer, or this is now y prime. Another example that we have in here, we are given r equals cosine of 2 theta all over 1 minus sine 2 theta, and we are going to solve for the derivative of r with respect to theta. Right? So in here, the forms that are involved would be the derivative with respect to x of u over v, since we have a quotient function here. So this is now equal to v multiplied by the derivative of u with respect to x minus u multiplied by the derivative of v with respect to x all over v squared. And also, we have in here, alright, so let me just change this color. Also, we have in here the derivative with respect to x of cosine of u, and this is equal to negative sine u du over dx, and also we have the derivative with respect to x of sine of u, and this is equal to cosine of u du over dx. Right? Now, these general formulas, we just considered u as a function of x, and since the given is a function of theta, then we're just going to change x with theta. Alright, so solving for dr over dt, dr over d theta, so that is now equal to, right, so using this formula in here, our v is 1 minus sine 2 theta, so that would now be 1 minus sine 2 theta multiplied by the derivative with respect to theta of cosine of 2 theta minus cosine of 2 theta multiplied by the derivative with respect to theta of 1 minus sine 2 theta all over, right? So this would now be 1 minus sine 2 theta quantity squared. So this is now equal to 1 minus sine 2 theta. The derivative of cosine 2 theta is equal to negative sine 2 theta multiplied by 2 minus cosine of 2 theta multiplied by the derivative of 1 minus sine 2 theta, so that would now be equal to negative cosine of 2 theta multiplied by 2 all over 1 minus sine 2 theta quantity squared. Now, if we're going to simplify the numerator, so this would now be equal to 1 multiplied by negative sine 2 theta multiplied by 2, so that would now give us 2 or negative 2 sine of 2 theta. And negative times negative, so that will give us positive 2 sine squared 2 theta. And in here, we have plus 2 cosine squared 2 theta. Alright, so if we're going to multiply this one with this, that will give us positive 2 cosine squared theta. All over 1 minus sine 2 theta. Quantity squared. Now, in the numerator, since we can factor out 2 in here, we'll be having negative 2 sine 2 theta plus 2 multiplied by sine squared 2 theta plus cosine squared 2 theta all over 1 minus sine of 2 theta raised to 2. We have here an identity which is equal to 1. Right? Because this is in the form of sine squared x plus cosine squared x, and that is equal to 1. Now, if we're going to simplify any further, the numerator can still be factored out, so we can bring out 2 in here. So this is now 2 multiplied by negative sine of 2 theta plus 1 all over 1 minus sine 2 theta raised to 2. Now, you will notice that negative sine 2 theta plus 1 can be written as 1 minus sine 2 theta. And since it is a common factor in the numerator and the denominator, then we can cancel out this one with 1 factor in the denominator. So this would now be equal to 1. Therefore, dr over d theta is now equal to 2 all over 1 minus sine 2 theta. So this is now our final answer. And that's how we solve derivatives of trigonometric function.